Rolls-Royce, a titan in the global aviation industry, is once again pushing the boundaries of innovation with its most ambitious engine to date, the Ultrafan. Known for its legacy of cutting-edge engineering and revolutionary breakthroughs in jet propulsion, Rolls-Royce has committed itself to transforming the future of air travel. From the iconic Merlin engine that powered Spitfires in World War II to the highly advanced Trent family that fuels some of the world's largest commercial aircraft, the company's history is steeped in technical excellence and bold innovation. But with Ultrafan, Rolls-Royce is not merely evolving, it is aiming to lead a technological revolution that could redefine the aviation landscape as we know it. The Ultrafan project is a direct challenge to General Electric's GE9X, which currently powers the Boeing 777X. GE's engine is no minor adversary. It boasts more than 110,000 pounds of thrust, a 134-inch fan diameter, and advanced materials designed for strength and efficiency. But Rolls-Royce is betting on a different strategy. Instead of focusing solely on brute power, Ultrafan has been engineered with an emphasis on fuel efficiency, environmental responsibility, and long-term adaptability. With a fan diameter of 140 inches, the largest ever built Ultrafan isn't just bigger, it's smarter, quieter, and significantly more efficient. To appreciate the magnitude of this leap, it's essential to understand the challenges inherent in jet engine design. A conventional two-spool engine struggles with balancing the optimal rotational speeds of its internal components, particularly as engine size increases. Rolls-Royce addressed this with its hallmark triple-spool configuration, allowing 3 independent rotating shafts to maintain optimal performance for the fan, intermediate, and high-pressure compressors. This innovation significantly reduces mechanical stress, lowers noise levels, and improves fuel efficiency principles that are now foundational in Ultrafan's architecture. But Rolls-Royce didn't stop there. The Ultrafan incorporates a planetary gearbox between the fan and low-pressure turbine. This allows the fan to spin slower while letting the turbine rotate faster, achieving unprecedented efficiency levels. This geared configuration is critical in reducing both noise and fuel consumption, giving Ultrafan a notable advantage over the traditional design of the GE9X. Furthermore, the gearbox alone can transmit up to 64 megawatts of power, a record-breaking feat in jet propulsion systems. Material science also plays a crucial role in Ultrafan's superiority. The engine integrates advanced carbon composite fan blades with titanium leading edges, combining lightweight design with structural resilience. It also leverages ceramic matrix composites, CMCs, that withstand higher temperatures and reduce the cooling requirements of hot section components. These innovations not only improve the thermal efficiency of the engine, but also extend component lifespans, reduce maintenance, and allow the engine to operate at higher pressures, all essential for next-generation fuel performance. What truly sets Ultrafan apart, however, is its remarkable bypass ratio, exceeding 15:1. In comparison, the GE9X has a bypass ratio of 10:1. A higher bypass ratio means more air is propelled around the engine core rather than through it, increasing thrust while decreasing specific fuel consumption and noise. This makes Ultrafan not only more efficient, but also more environmentally friendly, aligning with global efforts to decarbonize aviation. The engine is designed to achieve up to 25% greater fuel efficiency compared to earlier Trent engines, and up to 20% more efficiency than its rivals, a game-changing milestone in an industry under increasing pressure to reduce emissions. Beyond performance metrics, Ultrafan is a platform designed for the future. Its modular architecture allows it to be adapted to new fuel systems, including sustainable aviation fuels, SAFs, hybrid electric propulsion, and potentially even hydrogen-based combustion. This future-proofing element ensures that Ultrafan won't be just another engine, it will be the foundation upon which the next generation of green aviation is built. It's not just a power plant, it's a blueprint for what comes next, although GE9X holds an edge in thrust output, capable of delivering more than 134,000 pounds during static tests. This metric alone does not dictate the future of long-haul aviation. Airlines today are looking for efficiency, noise reduction, and sustainability areas where Ultrafan excels. By making use of additive manufacturing and 3D printed components, Rolls-Royce has reduced the weight and complexity of the engine, enabling quicker assembly, lower costs, and improved life cycle support. Over 20,000 parts in the Ultrafan are produced using additive layer manufacturing, reducing waste while enhancing structural integrity. These elements come together to form not only an engineering marvel but a strategic asset in the battle for dominance in the wide-body aircraft engine market. While the GE9X is tightly integrated with the Boeing 777X program, Ultrafan offers broader flexibility. It is expected to support multiple airframes and has been developed with scalability in mind, capable of being resized for different thrust classes and aircraft types. From narrow bodies to ultra-long-range platforms, Ultrafan also plays into Rolls-Royce's larger sustainability roadmap. By drastically lowering fuel consumption and CO emissions, it provides airlines with a viable pathway to meet the International Civil Aviation Organization's ICAO environmental targets. This will be crucial in the 2030s and beyond, as aviation regulators impose stricter carbon compliance standards and consumers become more climate conscious. The Ultrafan's quieter operation will also make it easier for airlines to meet airport noise regulations, further enhancing its market attractiveness. But market dominance isn't achieved by technology alone, it requires trust, reliability, and proven performance. Rolls-Royce has consistently demonstrated its engineering prowess with the Trent series, powering iconic aircraft like the Airbus A330, A340, A380, and Boeing 787. The Ultrafan builds upon this legacy with every innovation reflecting decades of experience and thousands of hours of real-world operation. Its first full-scale demonstrator has already passed several key milestones in testing, validating the performance claims and paving the way for certification and eventual commercial deployment. The race between Rolls-Royce's Ultrafan and GE's GE9X is not just a contest between two engines. It represents a clash of philosophies in aviation propulsion. GE is betting on brute force and continuity, while Rolls-Royce is wagering on innovation, efficiency, and long-term sustainability. As the world transitions toward greener skies, Ultrafan's advanced technologies, geared architecture, and low-carbon design may ultimately offer a more future-ready solution. It reflects not just where aviation is, but where it must go. In an era where airlines are under pressure to reduce costs, enhance environmental performance, and remain competitive, Ultrafan offers a compelling proposition. It blends cutting-edge engineering with an acute awareness of industry needs, regulatory pressures, and environmental responsibilities. The engine is more than a mechanical achievement. It is a symbol of what aviation can become when innovation is guided by purpose. As Ultrafan moves toward full-scale production and commercial application, its success could redefine the standards for efficiency, performance, and environmental responsibility in jet propulsion. In the coming years, we may very well witness a new aviation revolution, one powered not just by thrust, but by innovation, foresight, and a commitment to building a sustainable future for flight.